Primary 4 Science, Chapter 4 Solids, Liquids and Gases. As the lesson objectives, at the end of this presentation, you will gain knowledge about matter and non-matter, the differences between matter and non-matter, and the idea about the behavior and the properties of solids, liquids and gases. Now we are going to learn a lot of things about states of matter. Okay, my dear children. First and foremost, let's see what is known as matter. Can you see the mobile phone or maybe the laptop or whatever the device in which you watch this video? Yeah. Just lift it for a while. Did you feel the mass of it? Does it occupy a particular space on your table? Yes. Then simply the device which is placed in front of you can be identified as matter. Remember, anything which has a mass and occupies space is known as matter. Matter can be divided into two groups. What are they, children? Yes, living things and non-living things. Correct. When we are grouping matter as living and non-living things, we have to be concerned about some important points. Can you guess few of them? Yes, good try. Okay, now let me tell you important points that we should be concerned about before grouping matter as living things or non-living things. Observe the examples which are mentioned in this slide. Let's compare them. Living things grow, they move, they breathe, they eat and they reproduce. But when it comes for non-living things, they can't grow, they can't move by themselves. It means somebody should move them. They can't breathe, they can't eat, and also they can't reproduce. Okay, so these points you have to keep in your mind when grouping matter as living things and non-living things. What is mass? Mass means the amount of matter in an object. Okay, what I said? Mass means the amount of matter in an object. Mass can be measured in grams or in kilograms. We use grams in the form of simple G, and remember, kilograms are represented by simple K and simple G. kg, okay? Right. Different types of balances can be used to measure mass. Example, simple mass balance, digital mass balance, so on. When it comes to the simple mass balance, remember children, the mass of the object is compared with a standard mass. You have seen these in shops. But when it comes to a digital mass balance, the mass of the object is displayed on a digital screen. We say electronic balance also sometimes. I think you are more familiar with that term. Next, it's about volume. What is known as this volume? Let's see. Volume means the amount of space occupied by an object. All of you, look at your books. Do they occupy a space on the surface of your table or in the bookshelf? It means that the books have a volume. Okay? Volume can be measured from cubic centimeters, cubic meters, milliliters, and liters. Volume can be measured by using measuring instruments such as beaker, measuring cylinder, so on. Now we are going to discuss one of the main subtopics in our lesson, which is the displacement method. What is the name, children? What is the name of this method? The displacement method. Can you see the parts of the apparatus which are used in this displacement method? What are they? Yes, correct. A stone is tied by a string. The stone is immersed in the overflow can which contains water, isn't it? Yeah. What happens here is excess water get poured into the measuring cylinder through the spout. When the water level rises than the level at which spout is present, it happens. Okay. If you observe this scenario well, you will understand that the volume of water displaced due to the immersing of stone in water is equal to the volume of water. Okay, volume of the stone which is placed in water. So we have already discussed how the displacement method is done using this apparatus. Now tell me, what is the main importance of this displacement method? I mean, why is it conducted? To find what? Of course, remember, the displacement method is conducted to find the volume of objects which are irregular in its shape. What do you mean by irregular, children? No proper shape. The objects which do not have a proper shape. As you all know, in mathematics, we have different methods to find the volumes of regular shapes such as circles, rectangles, square. Now, look at the example that I have taken here. And I have asked a question also. What is it? If the volume of water displaced from the overflow can is 20 cubic centimeters, find the volume of the stone. Simply by comparing the water levels, you have to find the volume of the stone. That's what the question says. Now let's find the answer. Can you think about it for a while? Just compare the water levels and try to get the answer. I will give you few minutes. Few seconds actually. Right. As we learnt in the beginning, tell me the equation which we learnt. The volume of water displaced is equal to what? Yes, of course. It is equal to the volume of the irregular shaped object. So what is the irregular shaped object here? Stone, right? Okay. So tell me, what is the volume of displaced water which you can see in the measuring cylinder? Yes, it is 20 cubic centimeters. Okay, cm3 means 3 refers to cubic, cm refers to centimeter. So we call it cubic centimeter. Okay. If the volume of the displaced water is equal to the volume of the irregular shaped object, tell me, what is the volume of the stone? What is the answer? Definitely. Stone is an irregular shaped object. Therefore, the volume of the stone is also should be 20 cubic centimeters. Next is about non-matter. So before starting to explain about non-matter, I'll give you a clue like this. Opposite of matter is non-matter. Now let's revise the definition of matter for a while. We learned as matter is anything which has a mass and occupy space. Can you remember, children? Yes. If the opposite of this is non-matter, how to define it? Shall we try? Anything which do not have a mass or do not occupy space is known as non-matter. It is very simple. So let's mention some examples for non-matter. Yes, light, heat, sound, shadow, likewise. Okay? Now let's learn how matter is made of. Okay? So, if we consider many things around us, most of the things are made up of matter, isn't it? Just like everything has a building block, everything has something in which it is made up of. Okay? So there are very tiny particles. We call these tiny particles as matter. Okay? Remember, everything is made up of very, very tiny particles. Just like your house is made up of number of bricks, matter is made up of millions of tiny particles. If I mention some examples, the air around us, each drop of water, soil, they are entirely made up of millions of tiny particles. Okay? Right. States of matter. Matter exists in the forms of solids, liquids, and gases. Therefore, solids, liquids, and gases are known as states of matter. Let me ask you a few questions. Tell me, what do you call the solid state of water? Yes, we call it what, children? Ice. Okay. Next, what do you call the liquid state of water? As usual, we call it what? Water. Finally, let me ask you this question. What do you call the gaseous state of water which is getting released from a kettle when water is boiling inside? What is it? Yes, of course, we call it either steam or sometimes we call it water vapor. Let's see what are the special characteristics of solids, liquids, and gases. First, we will be discussing about the characteristics of solids. The solid particles are tightly packed close to each other in a regular pattern, as you can see in the diagram. As they have a definite shape and a definite volume. But remember one thing, children, solids cannot be compressed. Why? Because their particles are tightly packed with each other. So tell me some examples for solid materials which exist around you. Definitely you have a mobile phone or a laptop. You have a table. You have your science books with you, isn't it? So these things we say solids. Okay? Right. Next we have liquids. The characteristics of liquids. The particles of liquids are loosely packed and they do not have a regular arrangement. Therefore, liquids have a definite volume but no definite shape. Simply remember, liquids take the shape of the container in which we pour it into. Okay? And also another important point is liquids too cannot be compressed. Okay? Because anyhow, no matter loosely or tightly, particles are packed. That's the reason. Okay. Can you mention some examples for liquid things which you know? I know the main example which you will take is water. In addition to water, you can take paints, liquid paints, tea, coffee, oil, likewise. After that, now let's see what are the characteristics of gases. The gas particles are loosely packed and far apart from each other. A regular arrangement cannot be seen at all among these particles. Usually, gases do not have a definite volume or it doesn't have any definite shape. Okay, so if we take some examples for gases, we can take oxygen gas, water vapor, helium gas, nitrogen gas, so on. Okay, now it's the question time. Right, now I will be giving some questions. In these questions, I want you to use the practical and theoretical knowledge which you learnt so far. Okay, you have to use it. As you can see in the diagram, inflate two balloons so that they are of the same size. Tie one inflated balloon to each end of the stick. Hang the stick from the clamp of a retort stand. The stick should be balanced. Okay, it should be balanced. Now what you got to do is this. You have to burst one of the balloons by pricking it with a safety pin. Oh, now what happened? What happened to the stick? It got balanced or unbalanced, children? Yes, it got unbalanced, right? Okay. So now I am going to ask you two questions based on this phenomena. First question is, what happened to this stick when one of the balloons was burst? And the other is, what does this tell you about air? I will give you few seconds. Can you decide what should be the answer is? Okay, I will give you few seconds. Think about it for a while. Okay. First question was, I asked you, after you burst one balloon, what will happen to the stick? What will happen to the stick? Definitely it will get unbalanced. So as a result of this unbalancing, as you can see in this diagram, the stick will tilt. Okay, tilting means what? Getting slanted. Second question I asked was, what does this tell you about air? About air, what does it say? It proves that air has what? Yes, mass. Okay, air has mass. Right. Now let's go to the other question. In this question, this is what you got to do. A is an opened fizzy canned drink. Okay, right. B is an opened fizzy canned drink. Let's find the mass of can A using a digital mass balance. After about 2 hours time, let's measure the mass of can B. What has happened as you think? Yes, since the gas has been escaped in can B because it was opened for 2 hours time, right? So shall we answer the given questions now? Now what you got to remember is can B was opened for about 2 hours time and then only we measured the mass of it. Okay, so now keep that in your mind and answer these 3 questions. For these 3 questions also I'll give you few time. We'll try. We'll read the questions and we'll understand what it says about. Okay. First question is, what has happened to the mass of can B compared with mass of can A? What can you say? Definitely after 2 hours time, definitely the mass of can B has decreased. Okay. And then question B. What escaped from the canned drink after it was opened? We discussed it when I was telling you the question. What has escaped? Yes, gas. What else? Question C. What can we conclude from this experiment? What can we conclude, children? Same as earlier one, isn't it? Air has mass. Gas means air, so it has a mass. That's what we wanted to prove in this. Okay, next question. You have to understand these questions. They are very scientific. Okay. In this question, this is what you got to do. First of all, you have to crush a piece of paper and put it at the bottom of a transparent cup, as you can see in the diagram. Make sure that the piece of paper will not fall out of the cup when the cup is turned over. Add water into a tank until it is about 3/4 full. Okay, it should be about 3/4 full. I mean the water basin. And after that, turn the cup over and lower it slowly into the tank of water. Make sure the cup is not tilted. Okay. After the cup is fully immersed in water, lift the cup gently up. Make sure again that the cup is not tilted. Take the cup out of the water and remove the piece of crushed paper. Now you can answer these 2 questions. After you do this, you can answer. First question was what? Was the crushed paper wet or dry? What do you think about? Is it wet or dry? Yes, definitely it should be what? Dry. It's dry. Okay. And what does this experiment tell you about air? Yes, it says that air occupies space since air is also taken as matter. Okay, right, very good. Now you all attentively participated for the session. So we have come to the end of the presentation, which is related to states of matter. And thank you so much for listening attentively. Stay safe, children.